Martin, it's a pleasure to be speaking with you today as the chairman of Seawind Ocean Technology, but also as a new member of Wind Europe. Welcome to the association, and thanks for joining.
Thank you.
We first met, if I recall correctly, about 4 years ago, actually.
Sure,
I've been
correct.
following the development of Seawind since then, but it'd be great to hear from you about the journey the organization has been on since the company was founded.
It's a very long journey. Much before this company was founded, I started to work on offshore wind in 1998, I can tell you, in Germany. And the technology which we are bringing to the market today has been developed since the 70s, 80s of the last century, starting with NASA working on it. Then Jimmy Carter gave the development of the two-bladed wind turbine $330 million at the time. Today would be 1.5 billion euros. And this technology is very different from other wind turbines because it is based on a helicopter rotor principle, not on a propeller rotor principle with pitching blades. So it's not easy to introduce it to the market, but we have done a long journey to be here where we are today.
Yeah, so it sounds like exactly, lots of influences from the past coming in, and here we are, a major part of European industry, and great to see so many interesting plans coming out, not only from where we've been, but also where we're going.
Yes, and I can tell you that we are truly European. That means continental Europe and UK. Yeah? So we are truly European.
Well, good. I'm glad to hear that. Being a Brit lost in this Brexit land, it's great to hear your view on that. So, Seawind is developing a unique and really interesting two-bladed floating wind turbine design. If we focus first of all on the floating wind itself, what do you see as the advantages, but also the challenges of floating wind technology going forward?
Yeah. So the advantages are very clear. Floating wind can access deeper sea areas with less conflict with other users of the sea. The North Sea is a very special area, and there are a lot of competitors in the use of the North Sea. Oil and gas, telecommunication, but because it's shallower than the Atlantic or the Mediterranean, there's also an issue of bird protection and sea fauna protection. So birds go where the water is shallow. They don't go where the water is deep. So going to deeper sea areas, you avoid a lot of conflicts. Not only the winds in Europe are coming from the west. The North Sea is not to the west. The Atlantic is to the west. So there's also more wind in the Atlantic than in the North Sea. But I would say the conflict issue is the best point to see the advantages, and we can go into stronger wind areas. And the other big advantage which we have is we don't pile. We don't have to pile the foundation to the seabed. It is just float over and then anchored, so not invasive at all.
Exactly. And I think that nicely actually takes us on to what was going to be my second question, which is around understanding the technology in a bit more detail. So perhaps more specifically, what are the main benefits then when we look at a two-bladed wind turbine design in this context?
Yes, that's a very good question. I just need to add that we have a two-bladed wind turbine on a concrete foundation, and I will come to the second point after talking about the benefits of the two-bladed system. So the two-bladed system is based, as I have said in the introduction, on the helicopter rotor principle and not on the propeller rotor principle. So it has no blade pitching. It's not just about one blade less. It is about the fact that having a helicopter rotor principle, you can introduce what is called a teetering hinge, or also called a seesaw hinge. Loading from the wind on a rotor of a turbine, be it a two-blader or a three-blader, always creates asymmetric loading for several reasons. And these asymmetric loadings can be better, let's say, handled by a three-bladed rotor because of its 120 degree natural configuration, which is more stable, as a three-leg stool is stable. But a two-bladed rotor needs to cope with that, and it has to do so by introducing what is well known for in the helicopter industry, a teetering hinge, so that it can oscillate a few degrees around the hinge axis and take away this issue. But at the same time, and this is the big advantage of the two-bladed configuration, you can control the power output instead of pitching the blades. You just yaw into the wind as the leaders do. If the blade comes from here, you yaw into the wind. But if the wind is stronger than the rated wind speed, then you just rotate out of the wind. So you decrease, so to say, the circle which the wind sees into an ellipse, because the teetering hinge uncouples, so to say, the rotor from the shaft, and therefore breaks the gyroscopic system. A three-blader has to overcome large gyroscopic forces while yawing into the wind. Forget to be able to yaw out of the wind, just no way. So because the teetering hinge is, so to say, breaking the gyroscopic system, we don't have to deal with gyroscopic forces. This is the biggest advantage.
Well, that's fascinating, and it's really interesting to hear, those advantages over the more conventional fixed bottom turbines. And
A few words on the concrete foundation.
Yes. Okay. Yeah. Yeah.
This
Go
is
ahead.
very important, Phil, because again, it's concrete is seen as a CO2 polluter. That is not true. CO2 is in the cement, not in the concrete. But cement is only 15% of the concrete. The embedded CO2 content of steel is much higher for the same structural use as a concrete solution.
Yeah.
So there's much less CO2 embedded in the concrete than in the steel. And the other big advantage of the two-blader on a concrete foundation is that in floating conditions, the system moves with the waves, and a three-blader suffers so-called negative damping, without going into the details of this. Our solution, you can imagine the correct way, but we have to explain it to everybody here. You can imagine like as if between the rotor and the shaft there was a cardan joint. So this can move up and down as it wants, but the rotor stays always there nicely in front of the wind. So that's the other big advantage.
I think we've all been following the roller coaster of the US elections over the last few weeks, and of course, Joe Biden has more or less now been confirmed as the next president of the United States. Our view is that we believe that will result in more ambitious offshore wind targets and projects opening back up that were perhaps blocked for various reasons. Do you see a market opportunity for European developers in the US? And could opportunities in the US actually create supply chain issues for the further rollout of European offshore wind? And of course, the European Commission has some large targets for offshore wind itself.
Yeah, I don't see a problem there. I would not restrict it to the developers. I think there are opportunities. This creates opportunities. I don't think there's a risk. There's a risk for supply chain, and at the contrary. But it's not just for developers. It's for developers, for manufacturers and suppliers. For sure, the market will be now much bigger. So there may be some initial constraint in the beginning, but companies are adapting so quickly today to new realities. So I'm not concerned.
So I think, in that regard, to bring the prices down, we need to be looking at having, effective floating offshore wind targets, which Europe does now have up till 2030.
Yes.
Do you think it is achievable to be reaching these targets by that time frame?
Absolutely, yes. It's absolutely achievable. We have huge advantages in floating wind related to the build out of the offshore wind farms. We don't need installation vessels. Bottom rigs need the latest example, installation vessel for the new 12 megawatt generation of turbines. Jan de Nul building a new vessel which has a cost of almost half a billion, so almost 500 million euros. So we don't need installation vessels because our floating unit is the vessel. So we only have to organize the production in the various harbors around Europe and then tow them out to the site. So these targets which are there today are absolutely achievable and they should be more ambitious because of what I have said before. We have a huge advantage in the deployment of the systems. So they can be easily deployed just by towing over with tugboats. So we should really reach out for more, because if we want to replace CO2 emissions in the transport sector, it's not just about electrical cars. We need to replace diesel in heavy transport, kerosene in airplanes. Finally, also Airbus is now working on hydrogen airplanes. The vessels, the ocean-going vessels, the river-going vessels, and plus the entire chemical industry and the entire approach of the circular economy needs huge amounts of green hydrogen. That green hydrogen has to be produced offshore where the winds are the strongest. We shall never forget that the extraction of the energy goes by the power of 3. It's not linear. It's an exponential increase. So the more wind we have, the cheaper can be our electricity. So it's absolutely achievable, and it can be more ambitious.
Listen, that's great to hear. And Martin, it has been a real pleasure talking to you today. I've learned a lot myself, and thank you for sharing your views on offshore wind, and particularly floating offshore wind, and where our industry needs to get to. I wish you and your organization all the best, and really looking forward to seeing how the next few years progress for you.
Thank you, Phil. Thank you.
Bye bye.
Bye bye. Bye bye.